The National Electrical Code requires that the equipment grounding conductor of a non-metallic sheath cable be terminated to the enclosure. This means that the ground wire in a cable used for a duplex receptacle or light switch must be connected to the metal box. There are two common methods to achieve this. Firstly, connection through the yoke of the receptacle is permitted, meaning the grounding screw on the receptacle's metal frame makes contact with the metal box when the receptacle is installed. Secondly, and generally preferred, is to pigtail the equipment grounding conductor to the box. Pigtailing involves connecting a separate piece of wire, the pigtail, to the equipment grounding conductor and then connecting the pigtail to the metal box using a grounding screw or other approved method. There are several reasons why pigtailing is the preferred method. A more secure connection is established. When the equipment grounding conductor is pigtailed, it creates a dedicated and robust connection between the grounding wire and the metal box. This minimizes the risk of a loose connection, which can compromise the effectiveness of the grounding system. If the receptacle is replaced, the equipment grounding conductor is not inadvertently disconnected. When the equipment grounding conductor relies solely on the receptacle's yoke for grounding, removing the receptacle for replacement can temporarily or permanently disconnect the grounding path. Pigtailing ensures that the grounding connection to the box remains intact even when the receptacle is removed. This provides a continuous grounding path and protects against electrical shock hazards. Consistent grounding is more reliably assured. Over time, the connection between the receptacle yoke and the metal box can corrode or loosen, reducing the effectiveness of the grounding path. Pigtailing provides a more reliable and consistent grounding connection that is less susceptible to environmental factors and mechanical stress. To properly pigtail the equipment grounding conductor, follow these steps. Firstly, strip the insulation from the end of the equipment grounding conductor and the pigtail wire. Secondly, join the two wires together using an approved connector, such as a wire nut or crimp connector. Thirdly, securely attach the pigtail to the metal box using a grounding screw or other approved method. Ensure that the grounding screw is properly tightened to provide a reliable connection. Some metal boxes have a pre-tap hole specifically for grounding screws, while others may require drilling a hole and using a self-tapping screw. When selecting a grounding screw, choose one that is specifically designed for grounding purposes and is compatible with the metal box material. Grounding screws are typically made of steel or brass and have a green color for easy identification. When installing the receptacle, make sure that the metal yoke is in contact with the metal box. This provides an additional grounding path in case the pigtail connection fails. However, do not rely solely on the yoke for grounding. Always pigtail the equipment grounding conductor to the box for a secure and reliable grounding connection. It is essential to maintain the integrity of the grounding system. The grounding system provides a path for fault current to flow back to the source, tripping the circuit breaker or fuse and preventing electrical shock hazards. A properly installed and maintained grounding system is crucial for electrical safety. When working with electrical wiring, always follow safe work practices and wear appropriate personal protective equipment, such as safety glasses and gloves. If you are not comfortable working with electrical wiring, consult a qualified electrician. In summary, while the NEC permits grounding through the receptacle yoke, pigtailing the equipment grounding conductor to the metal box is the preferred method. Pigtailing provides a more secure, reliable, and consistent grounding connection, protecting against electrical shock hazards. It also ensures that the grounding path remains intact even when the receptacle is replaced. By following the proper steps and using approved materials, you can create a safe and effective grounding system that meets the requirements of the National Electrical Code. Always consult with a qualified electrician or refer to the latest edition of the National Electrical Code for specific requirements and recommendations. A thorough understanding of grounding principles and proper installation techniques is essential for ensuring electrical safety in residential and commercial buildings. Consider the application of grounding in various scenarios. For example, in a residential setting, appliances such as refrigerators, washing machines, and ovens require proper grounding to prevent electrical shock hazards. The equipment grounding conductor provides a path for fault current to flow back to the source, tripping the circuit breaker and disconnecting the power supply. In a commercial setting, grounding is even more critical due to the presence of more complex electrical systems and equipment. Grounding is essential for protecting sensitive electronic equipment from damage caused by voltage surges and electromagnetic interference. The National Electrical Code provides detailed requirements for grounding electrical systems in commercial buildings, including the size and type of grounding conductors, the methods of grounding electrodes, and the bonding of metallic components. Proper grounding is also important for preventing static electricity buildup, which can be a fire hazard in certain environments, such as manufacturing plants and chemical storage facilities. Static electricity can ignite flammable materials, causing explosions and fires. Grounding helps to dissipate static electricity, reducing the risk of ignition. Furthermore, consider the use of ground fault circuit interrupters, or GFCIs, in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. GFCIs are designed to detect even small amounts of current leakage to ground and quickly trip the circuit, preventing electrical shock. GFCIs are required by the National Electrical Code in certain locations and are a valuable safety device for protecting people from electrical hazards. Regularly inspect electrical systems to ensure that all grounding connections are secure and that there are no signs of corrosion or damage. Damaged or corroded grounding connections can compromise the effectiveness of the grounding system and increase the risk of electrical shock. If any issues are found, they should be repaired immediately by a qualified electrician. When making any changes or modifications to an electrical system, it is important to ensure that the grounding system is properly maintained and updated to meet the requirements of the National Electrical Code. Adding new circuits or equipment can affect the grounding system's performance, so it is important to consult with a qualified electrician to ensure that the grounding system is adequate. It is also crucial to use only approved electrical components and materials that are listed by a recognized testing laboratory, such as Underwriters Laboratories UL. Using substandard or unapproved materials can compromise the safety of the electrical system and increase the risk of electrical hazards. Always follow the manufacturer's instructions when installing electrical components and equipment. In addition to pigtailing the equipment grounding conductor to the metal box, it is also important to bond all metallic components of the electrical system together, such as metal conduits, enclosures, and equipment frames. Bonding creates a low impedance path for fault current to flow back to the source, ensuring that the circuit breaker or fuse trips quickly and effectively. The National Electrical Code provides detailed requirements for bonding electrical systems, including the size and type of bonding conductors, the methods of bonding connections, and the bonding of specific equipment. Proper bonding is essential for preventing electrical shock hazards and protecting equipment from damage. Regularly test the grounding system to ensure that it is functioning properly. Grounding tests can be performed using a ground resistance meter or a ground impedance tester. These tests measure the resistance or impedance of the grounding path, providing an indication of the grounding system's effectiveness. If the grounding resistance or impedance is too high, it indicates a problem with the grounding system that needs to be addressed. Grounding tests should be performed by a qualified electrician. Proper grounding is not only essential for safety, but it is also important for the proper functioning of electronic equipment. Sensitive electronic equipment can be damaged by voltage surges, electromagnetic interference, and static electricity. A properly grounded electrical system helps to protect electronic equipment from these hazards, ensuring reliable performance. It is also important to protect electrical equipment from lightning strikes. Lightning strikes can cause significant damage to electrical systems and equipment, as well as pose a serious safety hazard. Lightning protection systems, such as lightning rods and surge protectors, can help to protect buildings and equipment from lightning strikes. The National Electrical Code provides detailed requirements for lightning protection systems. In addition to the National Electrical Code, there may be local electrical codes and regulations that also apply. It is important to check with the local authorities to ensure that all electrical work complies with the applicable codes and regulations. Local electrical codes may have more stringent requirements than the National Electrical Code. The NEC states in Article 250.148, exception that for receptacle replacements in branch circuits, where the outlet box is surface mounted, the box is bonded to the grounding electrode conductor, and the box does provide an equipment ground, you are permitted to ground to the box via direct contact. For instance, imagine an instance where a metal box protrudes from a wall surface. Furthermore, the box is properly connected to the grounding electrode system. Lastly, the box provides a reliable ground. In this specific scenario, when replacing a receptacle, you could use the contact between the receptacle's yoke and the box itself as your grounding means. This is assuming you use self-grounding receptacles, of course. This exception, however, does not change the general and preferred practice of pigtailing the ground. Consider this a conditional allowance and not the rule of thumb. This section of the NEC aims to offer a practical solution for older installations while maintaining a level of safety. Be certain to evaluate the condition of the box and connections to confirm they are indeed providing a steady ground before using this exception. The NEC is updated every 3 years, so it is important to stay up to date on the latest changes and requirements. The NEC is a comprehensive document that covers all aspects of electrical safety, so it is essential to have a thorough understanding of its provisions. It is also important to attend continuing education courses and training seminars to stay current on the latest electrical technologies and best practices. Electrical safety is a shared responsibility. Everyone who works with electrical equipment or lives in a building with electrical wiring has a role to play in ensuring electrical safety. By following safe work practices, using approved materials, and maintaining electrical systems properly, we can all help to prevent electrical accidents and injuries. It is crucial to maintain the integrity of electrical enclosures. Electrical enclosures, such as metal boxes and cabinets, are designed to protect electrical components from the environment and to prevent accidental contact with energized parts. It is important to ensure that electrical enclosures are properly installed, maintained, and kept closed. Damaged or open electrical enclosures can create a safety hazard. Moreover, it is vital to be aware of the dangers of working with electricity near water. Water is a good conductor of electricity, so working with electrical equipment near water can significantly increase the risk of electrical shock. Never use electrical appliances or equipment in or near water, and always keep electrical cords and outlets away from water sources. If electrical equipment gets wet, disconnect it from the power supply immediately and do not use it until it has been inspected and repaired by a qualified electrician. It is also important to be aware of the dangers of overhead power lines. Overhead power lines carry high voltage electricity and contact with them can be fatal. Never work or play near overhead power lines and always maintain a safe distance. If you are working with tall equipment, such as ladders or cranes, be sure to check for overhead power lines and take precautions to avoid contact. If you see a down power line, stay away from it and call the power company immediately. Do not attempt to move or touch a down power line. Also, arc flash is a dangerous phenomenon that can occur when there is a short circuit or electrical fault in an electrical system. Arc flash can produce extremely high temperatures, intense light, and explosive pressure, causing serious burns, injuries, and even death. It is important to take precautions to prevent arc flash, such as wearing appropriate personal protective equipment, using insulated tools, and following safe work practices. Arc flash studies can be conducted to assess the risk of arc flash in a particular electrical system and to determine the appropriate safety measures. There are also circuit breakers that have arc fault protection which may assist in preventing arc flash from occurring. It is essential to have a written safety program. A written safety program is a comprehensive document that outlines the safety policies, procedures, and practices for a particular workplace or organization. A written safety program should cover all aspects of electrical safety, including hazard identification, risk assessment, training, and emergency response. A written safety program should be reviewed and updated regularly to ensure that it remains effective and relevant. In addition, it is helpful to have regular safety meetings and training sessions. Regular safety meetings and training sessions are an effective way to reinforce safety messages, provide updates on safety procedures, and address any safety concerns. Safety meetings and training sessions should be interactive and engaging, and they should provide opportunities for employees to ask questions and share their experiences. Safety meetings and training sessions should be documented to provide a record of the topics covered and the attendees. Furthermore, it is crucial to perform regular inspections and maintenance. Regular inspections and maintenance are essential for identifying and correcting potential electrical hazards. Electrical systems should be inspected regularly by a qualified electrician, and any necessary repairs or replacements should be made promptly. Maintenance should include cleaning electrical equipment, tightening connections, and checking for signs of wear or damage. A record of all inspections and maintenance should be kept. And it is important to use the right tools for the job. Using the right tools for the job is essential for both safety and efficiency. Electrical tools should be insulated and in good working condition. Never use damaged or defective tools. Use the appropriate tool for the task at hand and follow the manufacturer's instructions. There are a wide variety of specialized electrical tools available, such as wire strippers, crimpers, and multimeters. Furthermore, it is crucial to follow lockout-tagout procedures. Lockout-tagout procedures are designed to prevent accidental energization of electrical equipment during maintenance or repair. Before working on electrical equipment, the power supply should be disconnected and locked out using a lock and tag. The lock and tag should be placed by the person who is working on the equipment, and it should not be removed until the work is completed and the equipment is safe to be re-energized. Lockout-tagout procedures should be followed strictly to prevent accidental electrical shock. It is also helpful to use ground fault circuit interrupters, or GFCIs. Ground fault circuit interrupters are designed to protect people from electrical shock by detecting ground faults and quickly interrupting the power supply. GFCIs should be installed in areas where there is a high risk of electrical shock, such as bathrooms, kitchens, and outdoor locations. GFCIs should be tested regularly to ensure that they are functioning properly. Another important point is to be aware of the dangers of static electricity. Static electricity can build up on objects and people, and it can discharge suddenly, causing a shock or spark. In certain environments, such as manufacturing plants and chemical storage facilities, static electricity can be a fire hazard. Grounding and bonding can help to dissipate static electricity, reducing the risk of ignition. Anti-static mats and wrist straps can also be used to prevent static electricity buildup. And be aware of the potential for electromagnetic interference. Electromagnetic interference, or EMI, is a disturbance that can affect the performance of electronic equipment. EMI can be caused by a variety of sources, such as electrical equipment, radio transmitters, and lightning. Shielding and filtering can be used to reduce EMI. Proper grounding and bonding can also help to minimize EMI. It is also helpful to be aware of the potential for voltage surges. Voltage surges are sudden increases in voltage that can damage electrical equipment. Voltage surges can be caused by lightning strikes, power outages, and other events. Surge protectors can be used to protect electrical equipment from voltage surges. Surge protectors should be installed at the point of entry of the electrical service and at individual outlets. Moreover, it is crucial to be aware of the dangers of hazardous locations. Hazardous locations are areas where there is a risk of fire or explosion due to the presence of flammable gases, vapors, or dust. Electrical equipment used in hazardous locations must be specially designed and approved for use in those locations. The National Electrical Code provides detailed requirements for electrical equipment used in hazardous locations, and it is important to always call before you dig. Before digging underground, it is essential to call the local utility companies to locate any underground utilities such as power lines, gas lines, and water lines. Digging into underground utilities can be extremely dangerous and can cause serious injuries or property damage. Most states have a one-call system that can be used to notify all of the local utility companies of your intent to dig. Also, never overload circuits or extension cords. Overloading circuits or extension cords can cause the wires to overheat and create a fire hazard. Never plug more appliances or equipment into a circuit or extension cord than it is designed to handle. Use a power strip with a built-in circuit breaker to protect against overloading. Also, remember to replace damaged or frayed electrical cords. Damaged or frayed electrical cords can expose live wires and create a shock or fire hazard. Replace damaged or frayed electrical cords immediately. Do not attempt to repair damaged electrical cords yourself. And it is important to always use proper lighting. Proper lighting is essential for safety when working with electrical equipment. Use adequate lighting to see what you are doing and to avoid accidents. Use a flashlight or work light if necessary. Also, never use metal ladders when working near electrical equipment. Metal ladders can conduct electricity and create a shock hazard. Use a fiberglass or wooden ladder instead. And it is also important to keep electrical panels and equipment clear. Electrical panels and equipment should be kept clear of obstructions to allow for easy access in case of an emergency. Do not store anything in front of electrical panels or equipment. It is also essential to know what to do in case of an electrical emergency. Know what to do in case of an electrical emergency, such as an electrical shock, fire, or power outage. Know how to shut off the power supply and how to call for help. Have a plan in place for dealing with electrical emergencies. And it is crucial to always consult with a qualified electrician. If you are not comfortable working with electrical equipment, consult with a qualified electrician. A qualified electrician has the knowledge and experience to perform electrical work safely and correctly. Do not attempt to do electrical work yourself if you are not qualified. The National Electrical Code, NEC Section 314.40, addresses this topic and specifies the grounding requirements for boxes.